how it's made. Cars, grocery carts, rapid tooling and prototyping, and collectible coins. The automotive industry has seen a lot of changes in recent years. More and more robots are replacing workers on the assembly line. And it isn't just cars and trucks coming off the line anymore. Today's Hot Wheels are sport utility vehicles and vans. In the plant's body shop, they begin by putting together the front structure of the van. It's made up of the radiator support, 2 side rails, and clips on the front of those side rails for the bumper structure. Then they put this front structure onto the automated production line. Meanwhile, robots weld what's known as the ladder assembly. It's the backbone that supports the floor and sides of the van. It contains, among other things, the pockets that will hold the seats. Now the robots take the front end structure and the ladder assembly and weld them together. Elsewhere, robots work on the body panel for the passenger side of the van. The entire panel is made of one piece of galvanized steel. The robots weld reinforcements onto the panel so they can later attach interior finishing and other components. A transfer device swoops down and transfers the panel to the next station. The driver's side body panel, coming off another welding line, is headed there too. At that next station, robots have already installed an underbody with a floor panel on top of the ladder assembly unit we saw earlier. Now the robots weld the body side panels to the underbody. They also weld inner wheel wells to the body side panels. Then they weld on a roof. The van then rolls into the area of the body shop called closures. That's where they install the lift gate, the hood, and the doors. An inspector checks the gaps around the hood, looks for dents and dings in the body, and makes sure the doors are flush with the side panels. He marks any areas that need repair or adjustment with removable ink. The engines arrive at the plant already assembled. Workers just have to install and adjust a few components. Meanwhile, the van is off at the paint shop and then goes to the trim shop for glass, handles, and interior components. In the chassis department, the engine, transmission, rear suspension, and brake assembly are installed from underneath. This part of the assembly line has 2 tiers. The van goes on top, the components on the bottom. The machines that install the components have long pins that fit into holes in the van's underbody. This positions the components with precision. Workers hook up the gas tank manually. The seats arrive ready-made from a nearby factory. They simply clamp into place in the seat pockets that were welded onto the ladder assembly earlier. An automated machine mates the tire to the wheel rim. Then it inflates and balances the tire. Workers mount the tires, starting the nuts by hand, then tightening them with tools. Now the van comes off the carrier and goes full weight on its wheels for the first time. Workers start up the ignition and run the van through a series of tests. It's taken the plant about 24 hours to produce this vehicle, which will soon be on its way to a car dealership. Geomatics is a high-tech science whose objective is to gather geographic information, then study and use it. The tools of geomatics range from cartography to remote sensing to satellite imaging. We wouldn't be able to study the environment or monitor and develop our natural resources without geometric data. An Oklahoma grocer invented the first shopping cart back in 1937. He noticed his customers stopped shopping once their handbaskets became too heavy to carry. His basket on wheels became a rollaway success. This factory makes about 50 different models of shopping carts. They're built with heavy-duty steel and carbon wire. A single cart is made up of more than 150 wire pieces of various lengths and diameters. Automated machines bend the wires to form the cart's numerous components. To make the cart's basket, a worker uses a guide called a jig loader to line up the wires in a mesh formation. Then a machine automatically spot welds them together. The next machine applies 20 tons of pressure to bend the wires into a basket shape. A robot welds the sides of the basket. A worker then trims off the excess wire. An automated machine bends a piece of wire to form the handle of the shopping cart. They make the frame for the base of the cart, called the chassis, out of one thick tube that's almost 4 meters long. A robot welds the chassis using soldering wire melted by an electrical current. This creates a very strong joint. A die machine punches out casters that'll hold the wheels. They're made of thick steel for extra strength and durability. They spot weld the casters to the chassis. They clean the cart's metal components in a bath of soap and acid. Then they electroplate the metal with nickel, then with chrome as a finishing coat. It's finally time for the cart to take shape. They rivet the wheels to the chassis, then install the bottom rack. The basket comes next. They print the warnings on the plastic panel for the collapsible baby seat. Then the seat goes on, along with the plastic corner bumpers. They print the store's name on the handle inserts. The handle goes on last. After some final adjustments and a quality control check, The newly minted shopping cart is ready to roll. Every machine, from your vacuum cleaner to your car, is made up of a series of parts. Those parts are designed by specialized companies. They first build a prototype, then make the molds or tools needed to manufacture the part. They design the part in 3D on the computer. The computer then guides the machines that construct the prototype. One method divides the 3D drawing into cross-sectional layers just a few thousandths of an inch thick. It feeds this information to a laser that's directed at a tray filled with a light-sensitive liquid resin. The laser's light hardens the resin in the shape of the part, layer by layer, eventually constructing the prototype. They rotate the prototype under ultraviolet light for a few hours to cure the resin. Then they polish or paint the prototype according to the requirements of the design. Another prototyping method works much the same way, but uses a fine powdered plastic instead of resin. The computer guides the laser to melt the powder in the shape of the part, again, layer by layer. They extract the hardened prototype from the unmelted powder. Another method doesn't use a laser at all. The computer simply guides machinery to carve the prototype out of a hard material such as wood composite. Once a prototype is ready, they use it to construct a model of the part out of a very durable resin. They'll use that model to make a mold, then they'll use that mold to cast the part out of metal. The resin model dries at room temperature in 24 hours. Its surface must be smooth or else the mold will have defects. They attach channels that will guide the molten metal into the mold. Next, they fill the model with a mix of sand and a binding agent. They smooth out the surface, then number it for tracking purposes. The sand mix takes about 15 minutes to harden into a mold. Now they can finally cast the part. They carefully pour in the molten metal, in this case magnesium, heated to about 700 degrees Celsius. They block the hole with sand to prevent the metal from reacting to the air. The metal takes about 10 to 20 minutes to harden depending on the size of the mold. They crack the mold open on a vibrating conveyor. They use a plaster mold to cast parts that require a better surface finish. Workers position a box around the prototype to contain the plaster. The mold goes into an oven at about 300 degrees Celsius. It takes 48 to 72 hours to cure, but it's not ready for casting just yet. Workers first have to pierce some holes in it to let all the air escape, or else the metal won't flow into all the crevices, and they have to put in filters to keep out impurities. They strap the two halves of the plaster mold together, securing them with metal screws. Workers carefully pour in molten magnesium, using a special gas to prevent the metal from catching fire. Again, they seal the opening with sand. It takes the metal anywhere from 20 minutes to an hour to cool. Then they break open the plaster to remove the metal part. They cut off the channels through which they poured the metal. Then they polish the part using grinders and sanders. Then they paint it using special spray paint that adheres to magnesium. The part is finally finished. It takes several weeks to prototype and tool metal machine parts. When you think about it, even the machines that make these parts are made of parts that were made like this.